Hello, right, let's have a look at some algebra today. Okay, now, first thing about algebra is that we use letters, X, always a curly X so it doesn't get confused with a multiply sign, Y, Z, A, B, C, all this kind of thing, and we can use in conjunction with numbers and letters the same. Now, we're going to do simplifying, which is in algebra parlance is called collecting like terms. Now what does this mean? Right, so say you've got a big basket of fruit and they're all different fruit in the basket, sorry, and you want to collect big piles of various kinds of fruit. So you'd put all the apples in one pile, bananas in another, lemons and limes and so on and so forth. So you'd collect all the things that look like each other and put them in a pile. And that's exactly what we do with collecting like terms with algebra. Anything that looks like each other, we collect and put in a separate pile. So we've got one x there and two x's there. They look like each other, the x's, so we'll add those two together to give us 3x. And we've got 4y there and 1y there, so that gives us 5y. So we sort of have 3 apples and 5 bananas and sort of things. So we've separated them out. We've made it simpler, yeah? It's not such a long-winded thing. And so that's how we collect like terms. Now they've got to be exactly the same. If you have 2x squared plus 3x plus 5y squared plus 5y, there is nothing that is exactly the same as each other here, because although we have x's, these are x squared, so you can't simplify them. But if we had on the end there another 3x squared, you could simplify that bit and that bit together to make 5x squared, plus all the rest of it, 3x plus 5y squared plus 5y. So that's as far as you can simplify. And that's basically what it is. You get to the end of a algebra equation or whatever, you're trying to work something out, and it's always the tidy up line at the end is the simplifying. Now, we're going to multiply. Now, simplifying only happens when you add and subtract. So if you multiply algebra together, you see up here I've got 2x. This means 2 times x. Yeah, there's an invisible multiply sign there. Now if you've got x, y, this means x times y. Different from adding. If you've got x times x, you would multiply those two together to make x squared. Just the same as if you had 3 times 3 would be 3 squared, which comes out as 9, because you can do it with the numbers, but you can't go any further with the letters unless you know what the value of the x is. Right, so when we're multiplying, let's have a look at simplifying. So we're going to do 3x times 4x. And separate the numbers from the letters in your head or on paper, whichever way you want to do it. You multiply the numbers, 3 times 4 is 12, multiply the letters, x times x is x squared. 3x squared times 4x. Now, when you have an x on its own, you can consider that to be x to the power of 1. Yeah, we've just got one of them. And that is always, it just equals itself. So anything to the power of 1 equals itself. Now here, you can imagine you've got a 1 on there. So when you're multiplying things with indices, that's the squared, the cube, to the power of 4, to the power of 1, to the power of anything, you add them. So this, we're going to do 3 times 4, which is 12, x to the 2 times x to the 1 will be x to the 3. So you add the indices when you're multiplying together. So let's have a look at 3x squared y times 2x y to the 3. So you do the numbers. 3 times 2 is 6. You do the x's. X to the 2 times x to the 1 is x to the 3. And the y's, y to the 1 times y to the 3 is y to the 4. So you're just multiplying them. Now, consequently, when you divide, you subtract the indices. So if you have x to the 10 divided by x to the 6, that would be x to the 10 minus 6 is 4. Yeah, that way. I like to when I divide, I like to do it this way. Doesn't make any difference, so that I keep things in columns, and we'll see when it gets more complicated that 10 minus 6 equals x to the 4. And the reason why I do it that way is if we've got x to the 4, y to the 3, z to the 7 divided by x to the 3, y, z to the 5, x to the 4, 3, to divide the x's, so 4 take away 3 will just be a single x. Y to the 3 divided by y is 3 minus 1, don't forget the 1, yeah? That will be y squared, and z7 divided by z5 is going to be z2. And you might have some numbers up here. You might have 10 and 5. Therefore, you do the numbers. 10 divided by 5 is 2. That's it. That's what you do when you divide. You subtract. So you've got to be very careful with the ones. Now, the higher bit of this is when we have minus numbers. Minus numbers. Yeah. For example, we go back to multiply and we do x to the 4 times x to the minus 2. Now we're going to add the indices. It's going to be x to the something. So even though we're adding them together, it's like we're anding them together. So it's just 4 and minus 2. So 4 take away 2 is 2. So when you add, we're still adding, but it comes out as 4 take away 2. Why does that make sense? Why does that make sense? But if you have x to the 4 divided by x to the minus 2, then we're going to subtract. And this will be 4 minus 2, which is the same as 4 plus 2, which equals, x to the 6. No equals on the end there, x to the 6. So be very careful when you've got minus signs. So this is 4 and minus 2, and this one is 4 minus 2. When you've got two signs together like that, it means a plus. It means a plus. Right, next thing we did was expanding. expanding brackets. Now, when we're using the old rules of big maths and we're working with numbers, we might have 2, 3 plus 4. Big maths would tell us to add those two together, and there is another multiply sign that is never written. So this will be 2 times 7, which equals 14. But now watch this other way of doing it, and this is the way that we do it in algebra because we don't have any numbers. We multiply everything inside the bracket by what is outside the bracket. So 2 times 3 is 6, and 2 times 4 is 8. And you can see that 8 plus 6 equals 14 as well. So this is another way of doing the brackets, the B in the big maths. But we have to use this way when we're doing algebra. Yeah. So let's go to let's do a couple. So we'll gradually make them more and more complicated as we go. So 2 x plus 6. So 2 times x is 2x. 2 times 6 is 12. 2 times 2x plus 6. 2 times 2x is 2 times 2 is 4x. And 2 times 6 is 12. 2x, 2x plus 6. Now 2x times 2x, we can separate these out. So 2 times 2 is 4. X times x is x squared. Plus 2x times 6. Well, 2 times 6 is 12, and the x. So the more things you introduce, the more complicated it gets. So 2x plus 6y. So 2x times 2x, yeah? 2 times 2 is 4. X times x is x squared. 2 times 6 is 12. And x times y is just xy. Yeah? Good. What about minus signs? Surely it's going to make it difficult if we've got minus signs. X is, let's put an x, minus 3. So x times x is x squared, and x times minus 3 is minus 3x. So x times 3x minus 3. X times 3x is 3x squared minus x times minus 3 is minus 3x. Two x, 3x minus 3y. 2 times 3 is 6. X times x is x squared. 2 times 3 is 6. But remember, it's a minus 3, so it's minus 6. X times the y is xy. There. Oh no, there's no bracket there. Oh dear. Alright. Now, next bit. So that's oh, let's do another one, yeah? 2x squared, 3x squared minus 3xy. This is as complicated as it can get with a single bracket. So 2 times 3 is 6. X to the 2 times x to the 2 is x to the 4, because we add the indices. 2 times 3 minus 3 is minus 6. X to the 2 times x to the 1 is x to the 3, and the y on the end. So we did double brackets next. And let's do this. This is double brackets, and there's another multiply in between the two brackets. and these are quadratics, which we'll come on to later on. Right, so we're going to use something called FOIL. So the F stands for first, the O is outside, the I is inside, and the L is last. Now these are the position within the brackets, and this is the order which we multiply. So it's multiply. Don't add 4 and 5 together to get 9. It's 4 times 5. So first, so we do the first things in the brackets, which is the x and the x will give us x squared. Then we do the outside, which is the x times the 5, 5x. We do the inside, 4 times the x is 4x. And we do the last, 4 times 5 is 20. It's all plus signs, yeah? Now we always have to simplify here because you always end up, simplify, whoops, simplify. We always have to simplify here because you've done 4 things, so you end up with 4 terms. And we simplify it down to 3 by sorting out the x's in the middle. Plus 5x and plus 4x gives us 9x. That's how you do the FOIL. Now what happens if there's a minus sign in here? X minus 4 and x plus, I don't know, 6, we'll say. So FOIL, F-O-I-L, x times x is x squared. X times 6 is 6x. Minus 4 times x is minus 4x. And minus 4 times 6 is minus 24. Now we can tidy up these two middle terms. So we got plus 6x minus 4x. So we end up with a plus 2x in the middle. Minus 24 and x squared. Now let's put the signs the other way around and see what happens when we do this. X plus 4 and x minus 6. So FOIL again. X times x is x squared. Outside, x times minus 6 is minus 6x. Inside, 4 times x is plus 4x. And last is 4 times minus 6, which is minus 24 again. Now the difference here between the red one and the black one is the minus and the plus are the other way around. So we've got plus 4 minus 6, which makes minus 2x minus 24x squared. Okay. Only other thing to mention here is if there is oh no, there's 2 other things. So let's do 3. What do I do? X, yeah, 3x minus 3 and x plus 4. I wonder what this is, yeah? FOIL. 3x minus x is 3x squared. Outside, 3x times 4 is 12. 3 fours are 12x. Inside, minus 3 times x is minus 3x. And minus 3 times 4 is minus 12. Tidy up the middle 2. Plus 12 minus 3 gives us plus 9x. And minus 12 and 3x squared. Last little bit to mention is sometimes you will be presented with this and you've got a square and it will just say, oh, I wouldn't say factorize, it would just say not solve, just expand. Yeah, it won't wrap it up in a big question, just expand. So what you need to do with this, because it's everything squared, so you can rewrite this twice because it's this times itself, so it's actually squared. So we FOIL this one out, 2x times 2x, with 2 2's are 4, x times x is x squared. 2x times 4 is 8x. 2x times 4 is 8x, and 4 times 4 is 16. Middle bits added together, 16 plus 4x squared. There you go.